Hello, my name is Kate, and I'm your bio TA. I'm studying MCP and data science, and today I'm going to be talking about spreadsheets, which is so fun, and I feel like an adult when I talk about them, because adults use spreadsheets, I think. So, we're going to be introducing you to Excel and Google Sheets. Most of these things will work for both. They're about 99% the same, so let's dive in. Alrighty, so columns, rows, cells, and ranges. Hopefully we are familiar with the concept of columns and rows. It's going to be important. Cells are these little boxes. They are defined by the column they're in and the row that they're in, and we can call them by their column and row name, and that's how we get a cell. Ranges are rectangular groups of cells. They are defined by their top left and bottom right cells. For example, A1, B2 is this highlighted for cells. Formulas, we can use each cell like a calculator, which is kind of fun. The important thing to remember here is that whenever we want to use a formula, we're going to put an equal sign in front of our calculation. Another thing to note, this totally ignores white space, so you can too. I put this little space in between the equal sign and the 2 here because that makes things pretty for me, but it doesn't matter. The computer's going to ignore it, so you can too. If we wanted to find something like 2 times 11, which we might not know, we would put equals our calculation and then enter that into the cell, and the cell will automatically display 22. This feels a lot like using Python as a calculator. One notable difference, we're going to replace this double multiplication sign that we used to raise something to a power, and we're going to use a caret instead, which I think is better, but you can have your own opinion. We can also evaluate inequalities in cells. We're going to add this equal sign again because we are using a formula. This again works a lot like Python. We're going to have less than equals to, greater than equals to, strictly less than, strictly greater than. One difference is this little funky guy at the very bottom. This is our not equals to sign. In Python, we would use like equals exclamation point, I think. This is our equivalent here. So data types. The first would be text. This would be plain text. It is the default if no other type is detected. You can also force text with an apostrophe. For example, 2 would usually be recognized as a number, but if we put an apostrophe in front of it, it will be evaluated like text. It will act like text. So if we put an apostrophe in front of a formula, like equals 2 plus 3, when we enter that into the cell will display equals 2 plus 3 instead of doing the calculation and displaying 5. Text is aligned left by default, which we don't really care about, but for, purposes, educational purposes, you can see what I mean by this graphic on the bottom. Numbers, also fairly intuitive. Any number without an apostrophe will automatically be a number type. These are aligned right by default. If you want to check that some value is equal to some text, for example, let's say we want to check if A1 if the cell A1 has some text in it, this is a formula again, so we're going to put our equal sign in front, we're going to replace x with A1, and we're going to set it equal to some text. When we enter that into the cell will display true or false, depending on whether A1 matches some text. So if we try and do calculations with text, we're going to get a value error. Equals eggs plus 1, it's not going to work. Anytime we get an error in any cell, we can hover over the error in that cell to read the full description. The description is often going to feel less technical than some Python error that we would get. So currency, these are all values that reflect an amount of money. They are recognized based on the symbol that comes before them. For example, the $sign, pound or euro. Dates, a value that stands for a period in time. You can change the format of dates by selecting the cells you want to modify and going to Format and Number in your menu bar of Excel or Google Sheets. This can change little stuff like this dash could be a slash now. That's sort of like aesthetic kind of thing. You can do more. I invite you to play around. I also invite you to just like open up a sheet so you can kind of play around as we go through these formulas. Okay, so data types, the last one, logical. So we've actually seen these before. Logical cells take values true or false. They align in the center, which again, we don't really care about. So this little spiel at the bottom, Google Sheets is mostly case insensitive. So if you type true in lowercase, you'll get and you enter it into a cell, it will automatically be replaced by the all uppercase version. Kind of nice. So cell references. We've talked about this too. You can call a cell by its name to be used in formulas. For example, B2 times 2. Again, we put the equal sign because we're doing a calculation. So the important thing to remember here is that any referenced cell will update if any referencing cell will update if the referenced cell changes. For example, if B2 was originally 1, then my referencing cell will display 2, 1 times 2. If I update B2 to equal 6, then this referencing cell will update to 12 because of that change. So one thing to keep in mind is that we should not reference cells within themselves or through any chain. We shouldn't do that ever. This is called a circular reference. This graphic sort of displays these examples. If we end up doing that, we will get a reference error because Sheets doesn't know where to go to find that value. If you assign A1 to A1, there's nothing for it to go get. Avoid, generally. Okay, copying references. So this is really helpful. If you have some formula that you want to apply to every every row in the column A, you can do that. So all you have to do is actually assign the first cell. Let's say that we're doing this formula in the column B and we're working on the column A. So let's say I want to multiply every number in column A by 2. So in Python, we may use a for loop, something like that. Here, all we have to do is assign the first cell. We'll say B2 equal, or inside the cell B1, we'll say equals A1 times 2. Okay, and that will get the result that we want in this first B cell. Now, to get the result for all of the other numbers in A, all we have to do is drag that first cell down and all the way down through all the values in A. And the reference A1 in the first cell will update. It will become A2 in B2 and A3 in B3 and so on. Hopefully that makes sense. Also, if any of this doesn't, feel free to message me on Piazza or email me. So yeah. Okay, so then this second little fun graphic here shows the sort of pattern recognition that Sheets is really good at. So it will recognize this pattern looks like this pattern, and if you drag it down, it will match. You can also match, or as soon as you drag horizontally, it will match to the second column here. So horizontal copying is something that we are capable of as well. Okay, absolute references. So those relative references were the ones that shifted when we moved them. They were fun. Absolute references are stodgy. They don't change when you when you copy cells. We can assign an absolute reference with this $sign. For example, if we wanted to make an absolute reference to A1, we would say $A, $1. We can also do a partial absolute reference. So if we just want to lock this column, we could do $A, and then 1 will shift as we move it or manipulate it however we please. Okay, functions. So these are sort of built-in functions that are generally helpful. Let's go through them. Okay, so we're going to start with round and square root. So, okay, all of my optional arguments will be in brackets. So round needs to take some value. For example, 5.14. Round will then round 5.14 to the nearest integer, so 5. This means that places defaults to 0. If we wanted places denotes the number of decimal places that we're rounding to. If we specify places to be 1, then round will round 5.14 to 5.1. The square root value. Okay, so square root just takes a value. That's pretty simple, but it serves as a great example of like nest functions. So if we round 9.2, we get 9. If we square root that, we get 3. So just sort of like we work out from the first value that we put in. Okay, min, max, sum, average. Minimum needs to take at least one value. If it does take one value, it will return that value as it is the minimum of all the values you put into it. It can also take multiple values. I wanted to show that it can take this particular range and it will return 1. Here is that range. The smallest value was 1. So nice done. Nice job, min. Max works exactly the same way. Sum works the same way. I just wanted to show that you could, in theory, put in 2 ranges, and that could just be that many, just a bunch of values. I also wanted to note that this was kind of dumb, because I put A1, A5, B1, B5, when really I could have just said A1, B5, and that would have been the same thing. That would have been the same range. I don't know. I just wanted to show that you could put 2 ranges, and that would work too. So if you wanted, you could check that all of these values in A1 through B5 sum to 76. They do. You can believe me or not. Oops. Average works exactly the same way. I just put 3 values here, and the average was 12 2/3, so that was kind of nice. Rank. So rank takes a value and some data. It is important that the data contains that value so that the value can be ranked within the data. Is ascending defaults to 0. So is ascending defaults to actually not being true. So in descending order, let's look at A1. A1 is 7. I'm looking all the way up through 1, 2, 3, 4, and 7. So if I rank A1 through A5 and is ascending is set to 0, which is the default, 7 would be the highest number and it would rank 1. However, if I set is ascending to 1, which is essentially saying that is ascending equals true, then 7 would be the highest number and I'm going up to it, so it would rank 5. Okay, string functions, left and right. Basically, left takes a string and returns the first couple characters. It will default to the first character if you don't put a number of characters here. Left, if you just put Sunny in, it will return S. If you put Sunny 3, it will return the first 3, and you will return Sun. Right works exactly the same way. Len just takes the length of whatever text we put into it. For example, the length of cell is 4. Search, this is kind of cool. We can search for a string, and we can provide the text that we want it to search. Then we have concatenate. So concatenate takes at least one string. It would probably make sense to do more than one string since it combines one or more strings into a single string. My example, concatenate equals round space raccoons, and that would return round raccoons. We have to specify that we want this space in there. That's also true of punctuation. Okay, so weekday. This one feels fun. It takes any date that you put into it and provides the weekday. So the default type, it will give you that Sunday is 1 and Saturday is 7, and whatever date you put in there, it will spit out the corresponding day of the week in terms of a number. Type 2 assigns Monday to be 1 and Sunday to be 7, and type 3, Monday is 0 and Sunday is 6. Date diff is also super useful. So we have the start date, the end date, and the unit. The unit can be the year, month, or day. We can specify this with Y or D. Kind of fun. Now, it's a function that doesn't take any argument and evaluates to the current time. I say time, the current date. We can also specify the exact time if we wanted, but that's something we could change, we could fiddle with, but it evaluates to the current date. For example, if I wanted, this is helpful because if I wanted to do date diff and a whole bunch of start dates, and then instead of an end date, maybe I just want it to be today, so I could just use now. Okay, flow control. So these two functions, if or, are useful. So if takes a logical expression and the value if true and the value if false. And so if the logical expression evaluates to true, we will spit out the value if true, and false, we'll spit out the value if false. We can nest if functions. So I have this sort of graphic to explain this little nested if function guy. So let's say we're talking about we're trying to assign performance scores or something. So if our net, whatever, income, I don't know, income doesn't make a lot of sense. If our net profit, there we go, econ, I don't know anything about it, whatever. If our net profit, I guess, is less than 0, we can just call that bad. I think that makes sense. Yeah. And then if our net is greater than 0, then if this conditional is proven false, then we jump to this if value if false, which is another if function. Crazy, right? And then if we have now less than 150, and that's true, then that goes to acceptable. And if this is false and we have greater than 150, then we are good. And I think that makes sense. I invite you to like assign A1 to some, I don't know, 2, and then put this function into another cell and replace net with A1. You can kind of prove to yourself that this is correct and this will give you the results here. Or is another one of these flow controls. It takes at least one logical expression and returns true if at least one expression is true, and returns false if and only if all expressions are false. Okay, so count if, sum if, average if. So count if takes a range and a criterion and counts the number of times the criterion is met in the specified range. A criterion could be like, I want bears. I'm going to use bears. I don't know. I like bears. So the number of times bears appears in range, and that will be counted. So that's kind of what count if does. Sum if, same thing, except now we're going to say that A1 through A3 is our range, and A1 through A3 takes values bears, bees, and then bears. And B1 through B3 takes values 3, 4, and 8. So we're going to sum the B range every time the A range is equal to bears. So that would be A1 and A3. So then we're going to sum B1 and B3. We're going to get 11. Average if works exactly the same way as sum if. Okay, filter. This is our last function. Sorry, it's been a roller coaster. I know I've gone fast, but I was supposed to take 12 minutes, and I don't think I did. So filter takes a range and at least one condition. It evaluates to a filtered version of the range based on the past conditions. So the thing to realize here is that a condition is different than a criterion. If we go back, I set my criterion equal to bears for this sum if. That's not going to fly. A condition would be more like a logical. So something like greater than 5 was my example here. So A1 through A5 might be our range, and greater than 5 is my condition. So we're going to filter the range based on that condition. Alrighty, I think that is my last function. There are tons more. As soon as you type in equals into a cell in Google Sheets and you start typing letters, just a ton of functions pop up. All of the documentation is right there too. You can just click on the name of the function. It will tell you everything, which is really neat. So I invite you to explore. And that has been functions. Woo woo!